Alright, Chapter 5, we're going to look at some extra trig identities that we can use. We're also going to look at more in-depth solving of trigonometric equations. So we're just going to start with a selection of the trig identities from your sheet that I gave you. Before we get into those, I want to go over SOHCAHTOA and how it relates to our reciprocal functions. Okay, reciprocal functions, cosecant, secant, cotangent. They're also called the co-functions, which we'll get to later and see what the difference between calling them reciprocal functions and co-functions are. So sine from SOHCAHTOA we know is opposite over hypotenuse. Okay, and if we're on a grid, okay, our opposite would be our y value, our adjacent would be x, and our hypotenuse would be our radius, r. So sine could also be y over r. Or if you just have a right triangle like this, with these sides, it would still be y over r. Cosine is adjacent over hypotenuse. On the grid or on the triangle, it would be x over r, since this is the theta we're talking about. This is adjacent, that's the hypotenuse. Tangent is opposite over adjacent, which would be y over x. Now reciprocals, we can reciprocate these fractions to figure out what they would be. Okay, so if I want to know the cosecant of this angle, instead of opposite over adjacent, I'm going to take, instead of opposite over hypotenuse, I'm going to take the hypotenuse on top and the opposite side underneath it, or the radius over the y value. Secant's the reciprocal of cosine, so that would be the hypotenuse on top, the adjacent side on the bottom, which would be r over x. Cotangent's the reciprocal of tangent, so we get the adjacent on top, the opposite side on bottom, or x over y. All right, now some of the identities we're going to use just for this first section. The ones I want to focus on here are the ones where you can turn things into sine or cosine. Okay, so I'm not saying we'll never use these four here, but not very often. Okay, most times it's going to be easier for us to turn everything into sines and cosines because there's only two functions we have to worry about instead of six. Okay, so instead of having 1 over cosecant, it's just easier to keep it as sine, because if I can get everything in terms of sine and cosine, I can see if any of those cancel. And there's only two. Pythagorean identities. These both kind of come from our base Pythagorean identity, sine squared plus cosine squared equals 1. If I divide everything by cosine squared, sine squared divided by cosine squared becomes tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. And if I instead divide everything by sine squared, this would turn into 1, this would turn into cotangent, and this would turn into cosecant squared. Okay? The key to knowing and recognizing when we're going to use Pythagorean identities is anytime you have a trig function squared. So if I see cosine squared, I'm going to see if I can somehow use this identity. It could be in a different form. Okay, so let's say I have cosine squared and I don't have sine squared. Well, I can move this sine squared over and I could replace cosine squared with 1 minus sine squared. And maybe that'll help me when I'm simplifying trig expressions or solving a trig equation. Okay, so these can be shifted around to suit your needs. Even and odd functions, these are the only even ones, cosine and secant. All the rest are odd. The way to think about it is if it has a sign in it, then it's odd. Okay, which means if I put a negative angle in, I get the negative of that positive angle out. So an example would be sine of pi over 6. Okay, I know that that equals 1/2. So if I do sine of negative pi over 6, that's going to equal the negative of this. Or if I see cosine of negative x, I can just change that to cosine of positive x because cosine is even. If I see sine or tangent, we'll do tangent. If I see tangent of negative x, I can change that to negative tangent of positive x. Okay, because that's odd. So that's how those will work out when you're simplifying. Cofunction formulas. Basically, if you have pi over 2 minus your variable, you're going to turn it into its cofunction. Now, cofunctions are together, but reciprocals are kind of together too. So you have to keep those straight. Sine and cosine are cofunctions. They'll turn into each other if you take pi over 2 minus the variable. Okay, and the easy to remember cofunction is they're named the same thing. This is sine and the cosine. They're like co-owners, right? I'm the owner, this is my co-owner. I'm the host, and this is my co-host. They work together. So secant and cosecant, they work together. Tangent and cotangent. Now, tangent and cotangent are probably the coolest ones because they're cofunctions and reciprocal functions of each other. So you really don't have to worry about them. They always go together. Okay, if we're looking at reciprocals, then it's sine and cosecant, cosine and secant. Okay, still only one co per pair, whether you're talking about reciprocals or cofunctions. So let's look at how we can use some of these. Let's say they want trig values, okay? And they give me this. Well, this is a cofunction form, so I'm going to turn this into just tangent of x equals 8/3. And then on my right triangle, I can label, since tangent is opposite over adjacent, opposite, adjacent. They'd probably give you some more information to let you know if these are both positive or both negative. But then I can use my Pythagorean theorem to find my hypotenuse. So 8 squared is 64, plus 3 squared is 73. So this is the square root of 73. And now if I want to know what's the cosine of x, well, I just take adjacent over hypotenuse and rationalize. So 3 squared is 73 over 73. Okay. Same thing here. I can just turn this, since tangent's odd, I just turn this into tangent of x equals 8/3. So therefore, the tangent of the positive tangent of x would be the negative 8/3. And they'd have to give me more information because right now I don't know if the 3 or the 8 is negative, but one of them is. Maybe they tell me I'm in quadrant 2. Well, in quadrant 2, my x values are negative, so that's negative. I'd still get the same hypotenuse. And then I can find whatever trig value they're looking for. If we're simplifying expressions, okay, we're going to use those identities to try to get it down to something simpler. Let's see, I've got squareds here, and since I've got tangent on the bottom, I probably want to keep things in terms of tangent, hoping that one of them will cancel. So let's see what secant squared equals. Secant squared is tangent squared plus 1. So I'm going to replace that in here. So secant squared is tangent squared plus 1. I'm going to keep my tangent on the bottom. I'm going to distribute my negative sign in here. Okay, so on top here, I've got tangent squared minus tangent squared, so that's going to go away and leave just -1 over tangent. Now, something about when you have 1 over something, let's say I have 5 and then I have 1 over 5, okay? These are reciprocals of each other. So when I have 1 over tangent, this actually equals the reciprocal of tangent, which would be cotangent. I could show it a different way too. Since tangent is sine over cosine, so it's 1 divided by sine divided by cosine, that means I'm actually taking 1 and timesing by the reciprocal of the bottom, which would be cosine over sine. Cosine over sine is cotangent, so it's -1 times cotangent, so negative cotangent. Your check step here is to pick a value, something that's not normal, something that's not from your unit circle necessarily. So maybe pi over 7. I'm going to put pi over 7 in here, and here, and here, and see what number I get out. And I'm also going to put pi over 7 in here, and I should get the same thing out. So that's your check step. Just be careful when you're typing this in your calculator. So I'll show you how to do that. Okay, so in your calculator, you have to make sure you set this up right. So we're going to need parentheses around our numerator. We're also going to need parentheses around tangent, okay, around the whole function of tangent, because we can't put the squared there. We have to put it on the outside of the whole function. And when we type in our our secant squared, it's okay to do 1 divide because we're going to do division before we do subtraction. But again, you're going to have to put parentheses around the whole cosine function so you can square it. And then you're going to have to close the entire parenthesis around your numerator. So first, let's make sure in radians here. Let's store our value of pi over 7. Pi divided by 7. I'm going to store that as x. Okay? Now I'm going to type this first one in. So here's my numerator parentheses. Here's my parentheses around tangent. I want x. Close my parentheses around tangent and square my tangent. Subtract 1 divided by parentheses around the cosine. X, close my my cosine parenthesis, square it, close my numerator parenthesis, divide by tangent x. And I get that value. Now cotangent is cosine over sine, so cosine x divided by sine of x, and we want this to be negative, so just, I forgot to put the negative in, but negative, and we'd have the exact same answer. Okay? So that works, and I know that I've got the right answer now because it simplified and gave me the same answer out. Let's look at another one here. Here I'm subtracting fractions. In order to do that, I need a common denominator. So my denominators now are sine and cosine, so I'm going to need both of those in my common denominator. So I need to multiply this by cosine theta on the top and bottom. And distributing, I'm going to get cosine theta, sine theta, plus cosine squared theta. Over here, this is getting multiplied by sine theta on top and bottom. This is minus, okay, I'm going to keep that minus outside for now. This would be sine theta cosine theta minus sine squared theta. Distribute my minus sign, so I've got cosine theta sine theta plus cosine squared theta minus sine theta cosine theta plus sine squared theta, and this is all over our common denominator of sine theta cosine theta. Now if you notice, I've got cosine times sine, which is the same as this, so 1's plus 1's minus, those cancel. So I've got cosine squared plus sine squared, which is our base Pythagorean identity. So that's going to turn into 1. So I've got 1 on top, sine theta, cosine theta on bottom. And since we can always make it where we don't have a fraction with trig functions, I'm going to turn this so it's not a trig function. So 1 over sine is the same as cosecant. 1 over cosine is the same as secant. And this is simplified. And again, we can test this with our calculator. We use the same pi over 7 value. First, I'm going to have sine x plus cosine x, close my numerator, divided by sine x, subtract numerator, cosine x, minus, oops, close my parenthesis, minus sine x, close that, close the numerator, divide by cosine x. I get that number. Let's see if that's the same as cosecant. So I'm going to take 1 divided by sine of x. Divide. Just means I'm putting it on the bottom. So I'm not... 1 is the only thing that's going to show up in the numerator. If you don't like it this way, we could say, okay, times 1 divided by cosine x. If that's a little more clear. I get the same answer. So now I'm confident that I've simplified it the right way. So make sure you're doing these check steps just for peace of mind. I'll have the answer key also, but you should get in the habit of checking your own work. That way, on the test, or, I mean, when you actually get out of school and are in real world, you need to be checking your own work and figuring out ways to do that. If you get in the habit now of figuring out how to check your work when it comes to a real problem, you know, be it math or science or whatever you end up doing with your life, just make sure you're always checking yourself to make sure you're correct before you submit something. All right.